students. In this video, I am going to discuss OP directors and meta directors. Most of the time in first year organic chemistry and second year organic chemistry, we are going to use some terminology. What is that? So, toluene is OP director, phenol OP director, chlorobenzene OP director, nitrobenzene meta director. So how we can decide which is OP director, which is meta director? I am going to give best shortcuts to you. Okay, see, first I have given some note points. Plus M groups are ring activators. In previous video, I had explained mesomeric effect introduction part and how many types of conjugated systems are possible, and plus M groups and minus M groups also I have listed. So please go through that topic and come back here. And I had description box I had given some links also regarding OP directors and meta directors. Those also you can watch. You can understand more and more better. Okay. Now plus M groups are ring activators. That means plus M is nothing but he is giving electrons to the benzene ring. Down also I will explain this one. Plus M groups are ring activators, OP directors. Means that when the electrophile is attacking, the plus M group will decide the coming electrophile attacking. If no one is there on benzene ring, coming electrophile, it can sit in any carbon. Out of 6 carbons, any carbon it can sit, no issue. But somebody is there on benzene ring. Who is somebody? If it is plus M group or minus M group. Plus M group decided the electrophile attacking where? Ortho position, para position. Suppose minus M groups are there, those are ring deactivators. It takes electrons from the benzene ring. Such a way we call it as it is meta directors. Why we are meta directors? Any electrophile attacking, the minus M group will decide the coming electrophile attacking place is meta position. Why it is? I will show now. See, first I am taking aniline. This is one of the familiar example. It is the strong activator. In second year and first year also, we have two strong activator students, that is phenol and aniline. Aniline is the strong activator. Aniline is strong activator, strongest, and among all second year functional groups, aniline and phenol is strong activators. Among phenol and aniline, aniline is the strongest activator. See students, listen, this lone pair of electrons giving here. Once had given here, then what happened? This carbon gets 5 bonds. Already I had explained this concept in the previous video. Please watch it. So see, once it given electrons, now this carbon have 5 bonds. 5 bonds he cannot bear. Immediately this 5 electron shifts here. 5 electron shifts here. So then what you will get? What is the resonating structure? See students, how easy. I am not disturbing these 2 bonds. I am not disturbing these 2 bonds. As it is, you can write. See, this is double bond we are getting. Why? Because lone pair electrons it is giving. Lone pair is giving is nothing but pair of electrons is nothing but bond only, right? So now finally he is shifted here. This is negative charge. I had explained in the previous video. Pi lone pair in conjugation. This is pi bond lone pair. Alternative. Pi bond sigma bond lone pair. If this combination is there, definitely it can show conjugation. And pi sigma pi, this combination already had explained all the conjugated systems. Now I am giving here, see, pi sigma lone pair, it is in conjugation. See students, once we got this structure, further resonating structures, how it occurs. See, this negative charge can't be always this carbon. This negative charge is nothing but electron rich species. This carbon now giving this electrons to this carbon. Between this and this, between this and this. Okay, why is giving? Always negative charge, it is not stable, no? Then it is transfer to entire ring. So between these two now you are getting double bond. Now this carbon get 5 bonds. Immediately this can push here. Then what is the output students? This bond as it is you can write, and this is what? Double bond NH2. I am not disturbing this one also. And the next one, what is this? Negative charge shifted here, double bond here. And who is giving electrons? Who is taking electrons? This one. That's it. Now next output. What is the next output? See, now ortho, para, ortho positions. Double bond NH2 you can write as it is, NH2 plus. Okay. Now this this negative charge shift here between this carbon and this carbon. Okay. Now this bond shifted here. Why? Because it will get 5 bonds for shifting here. Shifting here means what is the charge? Negative charge. Bond shifted here means this double bond. This as it is you can write. That's all, students. That's all. Now afterwards what happens, students? This negative charge is giving back. Now this bond is giving back. Then finally what is the output? See here, negative charge given here means bond. This bond as it is you write, this bond as it is you write. Then this bond is giving back. Bond giving back is nothing but lone pair. Lone pair is nothing but bond only, right? That's it. See, what is the difference between first structure and last structure? First structure and last structure, I did not disturb atoms. Atoms, how it is same like that. Atom movement is not there. Only electrons movement is there. Only electron disturbances, 5 electrons. Here right side it started, double bonds. Here left side it started. That's it. These two structures we call it as resonating structures. That's why benzene you can write alternative double bonds like this, or else you can write alternative double bonds like this. Okay. This is we call it as resonating structure. Okay, finally what I am giving the conclusion point here. Plus M groups are, what is this group here? Plus M group. Plus M group. Conclusions. Plus M groups are ring activators. I have written ring activators. It is activating the ring, giving electrons and activating. Taking one, deactivating, giving one, activating, right? So, and finally, where we observed, see students, this is NH2 final output I am writing. Ortho position, this is ortho position. Ortho positions and para positions also previous videos I had explained. With respect to this one, second position is ortho position, and fourth position is para position, and this second position also ortho position. See, ortho, para, ortho. This is ortho, and this is what? Para, and this is what? Ortho. Now you look into this. If electrophile is attacking, electrophile is coming and attacking. Electrophile, where he will go and set either ortho position, para position, ortho position. Why? Because electrophile is positive charge. Here. Electron density more, where it is, where electron density increases, where electron density is more, ortho position, para position, ortho position. That's why all plus M groups are ring activators, and finally we call it as ortho para directors. Hope everybody clear. So now I am taking minus M group. Minus M group is nothing but it is withdrawing electrons from the benzene ring. Look into this, students, how easy this one. So here, compared to nitrogen and oxygen, who is more electronegative? Compared to oxygen and nitrogen, who is more electronegative? Oxygen is more electronegative. Oxygen is more electronegative. He will get negative charge and he will get positive charge. He will get positive charge, which is having positive charge, that is directly attached to benzene ring, seems to be electron deficient. It doesn't have electrons, means it start taking electrons from the benzene ring. Such a way, we will, once we got the double bond, see here what I am writing output, N O minus, this is D2 bond, lone pair donated to oxygen. Now here we are getting double bond, 1, 2, 3, 4 bonds. Okay, now what is the, students? We'll get here positive charge. We'll get here positive charge. Why? Because this electron shifted here. Now what I said in the previous video, pi, sigma, positive also it is in conjugation. See here, pi bond, sigma bond, positive charge, it is also in conjugation, right? So now you can see this positive charge is nothing but electron deficient. Then what happened? This carbon can't bear always positive charge, then he is taking electrons from the next carbon. This is coming here. Then what happens, students? What is the output? You can write, how easy? NO minus, don't disturb this one. Now this bond also don't disturb. See carefully, this bond shifted here between this carbon and this carbon. Who had given? This carbon had given. That's why he'll get positive charge. Now this positive charge entire ring it is rotating. See, now he is positive charge. Now next carbon is giving electrons. Why? Because always positive charge is nothing but electron deficient. He will not accept this electron shifted here. Then such a way this bond, new bond here I am writing as it is bond I am writing here, and double bond NO minus, this is O. That's it. Now he is given this will get positive charge. Now last one. Now giving back. This oxygen is giving back. This nitrogen is giving back. Now finally what is the structure, students? Here bond, here bond, here bond, and this is what? N double bond O. This is what we call it as nitrobenzene. What is this? Nitrobenzene. Finally, what we understood here, this is minus M group. He has taken electrons from the benzene ring. Minus M groups are, tell me what you observed, first structure and the last structure. Here double bonds only changes. Left, right to, like it started here and like this alternate. But here it started here. Okay, so this is the difference. This is the difference. Double bonds. Atoms I am not. Atoms I was not changed anything. Atoms as it is. Okay. Finally, minus M groups are ring deactivators. Means it is taking electrons from the benzene ring. Finally, these are meta-directors. How can you say it is meta-directors? Final conclusion point I am giving. What is the concluded point, students? Look into this. This nitrobenzene. Yes, nitrobenzene. Because of nitrobenzene, ortho position and again or para position, again ortho position. Ortho, para, ortho position. See, ortho, para, ortho positions I have got positive charge. Now electrophile is going and attacking. Electrophile, what is the charge, students? Electrophile charge is positive, right? So now he start attacking here, ortho position, repel. He start attacking para position, repelling. He start attacking what is this para? This ortho position, repelling. Only one position is positive, that is this position, or else this position. This position. Both we call it as meta positions. Meta positions. Had given clear explanation what is ortho and para positions in the previous video. Please go through that. Okay, ortho and para position. That's why finally minus M groups are meta directors. Hope everybody clear this topic. Okay, now next one. Its applications, some application questions on stabilities. Hyperconjugation structure stability questions I had explained already, students, and based on resonance also some questions we have that I am going to explain. See, first one, the one which is having more number of covalent compounds is more stable. Sometimes they will give 3-4 structures for us. Which is more stable, they will ask. Structure 1, 2, 3, they will give the names also. See students here. See, this is pi bond, sigma bond, here double bond, alternative. Pi, sigma, pi. If this is their conjugation. See what happens here. What happens here? What is this? It moves electron, right? It moves electron. Look into this. This pi electrons. Compared to oxygen and carbon and oxygen, who is more electronegative? Oxygen is more electronegative. Pi electron shifted towards oxygen side, Such a way what we are getting here, this is C plus, we are getting C plus O minus. After that, now again, what is this? Pi bond, sigma, positive charge. Pi, sigma, positive charge. Again he is in conjugation. Then he is giving electrons. Such a way this bond shifted here. The CH, O minus. Now who is giving here electrons? Positive. Plus carbon. That's why positive charge. See, first one, who is more stable means more number of covalent bonds. Where we are getting. See, here covalent bonds is nothing but both sigma and pi. Students, both sigma and pi bonds. Here 2 bonds, 3, 4, 5, 6, 7, 8, 9 sigma bonds. 9 covalent bonds. Here 9 covalent bonds. Here, if you count here, you will get 8 covalent bonds. Here also 8 covalent bonds. So finally, more number of covalent bonds is nothing but more stable. Structure 1. What about structure 2 and 3, which is more stable? Less charge separation is more stable. Less charge separation, here very close, no, less charge separation is more stable, then more charge separation is less stable. That's why 1 2 3 like this. Clear? So you can practice this question, students. It will take time to understand starting, but it is very easy. Most important for mains level and advanced and NEET level also. Now next one, resonating structures with atoms having enough number of valence electrons are more stable. See students, if you calculate here how many bonds, 3 2s are 6, 6 plus around carbon how many bonds, 3 bonds, 3 2s are 6, 6 plus 2 8, 8 electrons here. Nitrogen 1 2, 2 3 bonds, 3 bonds means 3 2s are 6 electrons, 6 electrons and 6 electrons, what is this? What is this? This is a, this is lone pair is there, no, lone pair is there, then totally 8 electrons. Calculate 1, hydrogen 2, and this is 3 bonds, 3 2s are 6, lone pair 1, totally 8 electrons. What about this carbon? Here 2 bonds, 2 2s are 4, 4, this is 1 bond, 3 2s are 6, 6 electrons only, 1 is deficient, it is not having enough number of electrons, at least one atom do not have enough number of valence electrons, that is less stable, little less stable. It is more stable or not, we can check it here. 3 bonds, 3 2s are 6, 6 plus 1 bond 4, 4 totally 8 electrons. Did you understand? Around carbon here 3 bonds, 3 hydrogens, and this is 1 bond, totally 4 bonds, 4 2s are 8 electrons. Next nitrogen 1 2 3 4, 1 2, hydrogen 1, here 2, here 3 4, so 8 electrons, 4 bonds means 8 electrons. Now this is 2, this is 2, 8 electrons. Covalent bonds is nothing but mutually sharing, no, so that's why while counting nitrogen also we have to count this bond, while counting carbon also we have to count, everywhere same like that. See, each and every atom having enough number of valence electrons, 8 electrons. Enough number is nothing but according to Lewis, which is having 8 electrons in the valence shell, it is more stable, right? This is more stable, this is less stable. Clear? Now next one, among the resonating structures with less charge separation is more stable. Less charge separation is more stable. Already had given this point. More stable, more charge separation is less stable. You can write the structure, students. You can write the structure. So here pi, sigma, pi, it is in conjugation. Okay, CH2 double bond, CH, this bond we can write here CH, CH. Next, these given electrons, no, given electrons, this carbon means you will get positive charge, positive charge. This bond shifted here, double bond. Okay, so what is this? Double bond. Then CH, CH2 minus, he has taken no minus. Now next again see, pi sigma positive charge, pi sigma positive charge, and this is also pi sigma negative charge. Again it is in conjugation, again it is in conjugation. This electrons away. Then what you will get, students? This carbon had given means positive, and this is what CH double bond, CH, CH. Next what you will get? Your CH double bond, CH, CH2. So like this. Now see, this is enough number of bonds, more number of covalent bonds. Always the first structure has more number of covalent bonds. There is no doubt. Here 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 covalent bonds are there. So definitely structure 1 always more stable. Structure 1 always more stable. Okay, in all cases. Next structure 2 and 3, which is more stable? 2 only. Why? Because less charge separation. Less charge separation. Here charge is very close, then it is more stable. Then here more charge separation, end terminals, then third one. So like that we are going to solve the questions JEE and NEET and advanced program. Okay students, hope everybody clear. I am giving one more important point. Appropriate charge on appropriate atom. Appropriate charge on appropriate atom is nothing but, you can better to understand like this. Suitable charge on suitable atom also. Suitable charge on suitable atom. Suitable charge on suitable atom means that suppose oxygen is there, suitable charge is minus. Fluorine is there. What is the suitable charge? Minus. If you have taken oxygen plus, that is not suitable charge. Why? Because generally oxygen is more electronegative element, is the second most electronegative element in the periodic table, right? So the suitable charge is nothing but negative charge, right? So now you can look into this one. How we can write the structure? This is negative sigma lone pair. Negative sigma double bond. That is also now shifting here. Finally what you will get? CH3 CO minus double bond CH2. This one. See students, suitable charge and suitable atom. Suitable charge and suitable atom. So this is more stable. Structure 1 and 2. Structure 1 and 2. Which is more suitable? This is oxygen has suitable charge. That's why it is more stable. More stable. Clear? Like this. One more point is there. Anilinium ion. What is this students? Anilinium ion. Anilinium ion is more stable or not? What is this anilinium ion? Is it possible resonating structures or not? They are asking. Anilinium ion, NH3 plus. NH3 plus. Around nitrogen we have maximum 5 bonds, students. Why? Because its valency is 5. Covalency is 4. Covalency is 4. Valency is 5. Around nitrogen how many bonds now? 3. And this is what? 4 bonds, right? And 4. Clear point. Now what we will get here? So resonating structures. Is it possible anilinium ion? Look into this anilinium ion. Actually resonating structures, but it is not possible because nitrogen is having more number of electrons, exceeding valency. Exceeding valency. So that's the reason it is not possible. If you write this structure, you can understand. Double bond NH, NH, NH. Okay, now this one like this, and positive charge. Here you are getting positive charge. Okay, now see around nitrogen how many? 1, 2, 3, 4, 5. 5 bonds is nothing but it is exceeding valency. Its maximum covalency is 4. Exceeding valency. Exceeding valency. Maximum covalency equal to 4. That's the reason it is not possible. Resonating structures not possible. You will get questions like this also. Okay, totally around nitrogen maximum valency 5, but valency 5 compounds are less. NCl5, NCl3, we have learned one point. NCl3, NCl5 is more stable, means NCl3. While NCl5 valency of nitrogen is 5, but due to lack of d orbitals, its maximum covalency is 4. Around 5 bonds means it is not stable. That's why further resonating structures it is not possible. Okay. Now next, some other application questions I am explaining here, students. Acidic nature they are asking. Acidic nature. Most important questions. Most important questions. Phenols. Phenol more acidic. Why phenol is more acidic? He is losing hydrogen fastly. Why he is losing hydrogen fastly? See, who is giving hydrogen fastly? Hydrogen giving fastly. Hydrogen giving fastly, that is more acidic. Why he is giving fast? You will go, I will be happy. Means see, after losing hydrogen he forms O minus. O minus is nothing but phenoxide ion. Phenoxide ion is more stable due to resonance. What is the resonance, students? What I said, resonance, negative charge, and sigma pi bond is there. It is in conjugation. See, it is in conjugation. The entire ring distribution of electrons, entire ring, more resonating structures you will get it. More resonating structures means more stable. That's why after losing hydrogen also, the rest part is stabilized by resonance. This rest part is stabilized by resonance. So that is more acidic. Okay, suppose alcohols are there, CH3, CH2OH. So it is less acidic than alcohols. Here also it is less acidic than phenols. Why? What is the reason? See students, here also it loses hydrogen. But after losing hydrogen, see CH3, CH2O minus. This is what we call it as ethoxide ion. what we call it as ethoxide ion. Ethoxide ion is less stable. Ethoxide ion is less stable due to plus psi effect. Due to plus psi effect. So what is this, students? What is this? Oxygen having negative charge. This negative charge is always not stable. If it distribute to the system, it distribute to the transfer to the system, giving to the system, then it can stabilize. He is not ready to take. Oxygen is electron rich, ready to give, but he is not ready to take. Why? Because these are plus psi groups. Plus psi groups are electron releasing groups. These are already having electrons. Why to take? It is not taking. Negative charge is more. Negative charge is more, it is there, that is unstable. So here he is losing hydrogen, but he is not fastly losing hydrogen. That is the reason finally we can say it is acidic, less acidic. You can write what is the conclusion point. Conclusion point: phenols are more acidic than alcohols. Phenols are more acidic than alcohols due to, what is the reason? Due to the formation of phenoxide ion. Due to the formation of phenoxide ion. Phenoxide ion, which is stabilized by resonance. Which is stabilized by resonance. But what I'm going to give one more link in description box, students. Acidic natures I had explained. Please go through that also. Okay. See here, alcohol is also losing hydrogen, but after formation, after that it forms alkoxide ion, ethoxide. If you take ethyl group, ethoxide, methyl group, methoxide, like that. Alkoxide ion. Alkoxide ion is destabilized by inductive effect. Inductive effect, most important. I said starting itself, most of the concepts we are learning, most of the concepts time we are giving one point: due to inductive effect, due to mesomeric effect, due to resonance effect. If you don't have command these topics, then next questions you don't understand. So these 4 videos, electronic effects, totally 8 videos I have done, students. Totally 6 to 7, 8 videos is nothing but electronic effects. Inductive effect 2 videos I have done, hyperconjugation 2 videos I have done, mesomeric effect 2 videos I have done. Along with this, at description box I am giving another links also, OP directors and all. Totally 8-9 videos I have given to you. Please all videos you can see, and finally you will get very good command during examination while solving questions also. Thank you, students. Thanks for watching. Please give likes and subscribe and encourage our channel. Thank you, students, once again.